Hi everybody, welcome back. This is Mr. Defy. Today I'm going to talk about point-slope form. Point-slope form is very different in appearance from its brother or sister, slope-intercept form. Point-slope form has a very specific use, as the name might suggest. Point-slope form is used when you know the point and a slope of a line, and then you can generate the name of that line through this function that you see here in red. So let's go ahead and break this down by its components. So first I want you to notice that there are two y's and there are two x's here. However, this second y that you see over here does have a little 1 there, and the same with this second x over here. Now, there are many ways to think about this, but the way that might help you practically is to think of it as that one y, that 1 on the y means that you need one y value, one output number. And the same thing with the x. That 1 means that you need one input number or one x value. And the only place that this can come from is a point, as the name might suggest. So if we look at a point, every point has an ordered pair. So a point is always given by an x followed by a y coordinate. And just to remind you, other words for x would be considered an input number. X is also considered a part of the domain. Okay? And with the y, this would be part of what's called the output and part of the range. So I just want to quickly throw that out at you as a quick review. But anyway, so x and y represent a single point on the entire universe of the coordinate plane. So out of all these points, you need just one to complete this function called point-slope form. And so that's what the x and y mean. Just give me one x value, one input, one y value, one output. The letter m, as you might know by now, this represents our slope, which we will either know because it's given to us, or we will have to calculate, in which case we will have to figure out the change in y over the change in x. Okay, so just to clarify, this means an output value, and this over here means an input value. Input value. So having said that, what we need to complete this is we need the slope and we need a point. So let's go ahead and jump right into our first example and see how this works. So it says, what is a linear function of a line with a slope of -3/4 or 3/-4 and which passes through a point at 6, 7. Now right away you should note that there's some information that's given to you here to work with. First of all, it says the slope is 3/-4, and secondly it says that there's a point on this line at 6 and 7. So what I need to do in my head is write down or think about what I know right away. And what I know is, number one, I have a point which is at 6, 7. And once again, this represents our x and this our y, which we will need to complete that function. Secondly, I know that the slope is given to me, and that's 3/-4. Now, you could write this, by the way, you could write the slope by changing the negative's position. Instead of it being at the denominator, you could put it in the numerator, and it would mean the same thing. So -3/4 and 3/-4 are exactly the same thing as each other, okay? There are slight differences in terms of the direction it takes you when you're making the line, but don't worry about that right now because we're not going to graph this. So let's get back to the question. What we have to do is we have to write the function for this information, and I don't have any information about a y-intercept. So this is clearly not a job for the slope-intercept form. This is a job for the point-slope form because I have a point and I have a slope to work with. So I'm going to go right ahead and open a blank equation right here. I start with a blank one so that I know where I need to place things. And I know that I need to put something there, here, and here. Okay, so in the end, I'll have 3 numbers in those spots. The first one, if I go left to right, the first one says, give me a y number. So the y number I have is 7. So this becomes y minus 7. Now that may seem like I'm making the 7 a negative, but really what it's saying is that what I'm inserting into that y1, y sub 1, is the output 7 from this point that I'm given. Okay, it ends up looking like that because that's the design of the function, y minus 7. The slope is 3 over negative 4, or like I said earlier, negative 3 over 4, however you want to write that. On the inside, you have x minus. Now, the x sub 1 means give me the x coordinate of the point we have. Now, we have a 6, so this becomes x minus 6. And that, believe it or not, is the function. Okay, we're not going to do anything more with it because we have achieved the task we were told to do, which is make a function for the information. And there it is. So let's go ahead and move on to example number 2. What is a linear function of a line that passes through points 7, negative 9, and negative 3, comma 5? In this example, what makes this different from the previous one is that we are not told the slope. What we're given instead are 2 points that the line passes through, and we have to generate the name of that line. So unlike example 1, what we have to do is a little more work than the first example because we have to actually get the slope. Okay, so I'm going to set up my function blank, and this serves as a map for me. This is my end game. I need to end up with my function looking like this, again with numbers in these spots, here, here, and there. Okay, but like I already said, I don't have a slope. And although I do have 2 points and I could choose an x or y from either one of them, I don't have the slope. So I need to get that first before anything. So I'm going to get the slope. Okay, and to do this, I need to understand that this is about my change in y over change in x. So for my change in y, I can choose negative 9 to begin with, or I can choose the 5 to begin with. It really doesn't matter, but you have to pick one. So I'll go with negative 9 first. So negative 9 changes into a 5. And then in the same direction with the x's, 7 changes into a negative 3. And I have a double negative there, so this will have to become a positive. And that will give me, in the numerator, negative 14, in the denominator, 7 plus 3, which is therefore 10. And if I can reduce, I always should. So dividing each of these by 2 will give me my final form of this slope, which would be negative 7 over 5. Now that is not the end. That is not our answer that we're going to wrap up and walk away from. This is only the slope, which I then need to take back to the function and replace the m with. So I'm going to go ahead and do that right now. So I have y minus y1 is equal to negative 7 over 5 times x minus x sub 1. And I've only done it that way because I want to show you that what we've done in blue over here now takes the place of that m over there in the function, okay? And now what we need to do is get our x and y. Now I have 2 points, which makes this pretty easy for me because I can choose one of these points to work with. It doesn't matter which one because both points lie on the same line anyway. So it's like a brother and sister belonging to the same family. They have the same blood. And so the blood of these 2 points, or the family, is the line itself that they sit on. So choose whichever one that you feel most comfortable working with and go ahead and plug them in. So I'm going to choose either of the 2 points. Or either of your ordered pairs is a better way to put it. Because that's what they are. They're not visible points yet, they're just ordered pairs. So I'm going to choose, in my example here, I choose 7, negative 9. Okay, now that's my choice. If you wanted to choose negative 3, 5, go right ahead. This is my x, this is my y. Now that I know that, I go back to the function and I replace the y and x, the y sub 1, x sub 1, with what I know. Again, this is going to become a number, and so will this over here. And this is what you get. You get y minus. Now, what I'm substituting is a negative 9. So it's y minus whatever number is my y, and that happens to be a negative 9. So it's y minus a negative 9, and that's a double negative. So that will be something I have to take care of. That will become a positive. So I need to rewrite this in my next step. For now, I have negative 7 over 5, and then this is x minus, and going to my ordered pair, my x of my choice is 7, so it's x minus 7. And the last thing is just go ahead and rewrite this so it's nice and clean. So it's y plus 9 equals negative 7 over 5 times x minus 7. And that is a function for this question. Okay? In the next example, we have to graph the line of the function. Now, to graph the line of this function, we need to know two things. Or three things rather. We need to know what form this is. And this is point-slope form. I know that because slope-intercept form is y equals mx plus b, and that looks nothing like slope-intercept form. Okay, so I don't have an intercept point to work with. What I have instead is point-slope form. This is point-slope form. And because it's point-slope form, what that means is that there lies within that function a slope and a point that I can use to generate my graph. So I'm going to go ahead and pull those things out of there. My slope is right here. And that's a guide for me. So my slope, which is my change in y over change in x, is negative 5 over 6. And directionally, what this means is that the negative 5 would tell me to go down from a certain place, and the 6 would tell me to go to the right from a certain place. Okay? So I have those directions clear in my head. Now, the point will come from this number here and this number here. But I want you to take note of something. This over here is a minus right here. That's a minus 3, whereas on the 2 there's a plus, and there's a reason for that. The reason is because originally, before it looked like this, it looked like this. Remember, point-slope form has minuses in the design of that function. So it used to look like this. It used to be x minus, I'm going to slow down here, x minus negative 2. Okay, it was like that in the beginning. And then, because of the double negative, it became a positive 2, which means that our original x value was actually a negative 2. It was a negative 2. Our y value is just positive 3, because that minus sign on the 3 is part of the natural design of point-slope form. It's y minus y sub 1, as you can see over here. See? A minus sign right here, and a minus sign right there. That's part of the design of this function. So anything that you see that is a plus sign means that originally the number had to have been a negative. So what this means is that I have a point right here. My point is at negative 2, 3. And with that, I can go ahead and create my graph. So here it is. My graph will look like the following. I go to negative 2, 3, negative 2, 3, put a point right there. And then I use my slope as a guide to my next point. So my slope is negative 5 over 6. So I go down 5, 1, 2, 3, 4, 5, and over 6. 1, 2, 3, 4, 5, 6. And then I can go ahead and make my line. Okay? And there it is. Excuse me. So it's not the most accurate line, but you have the idea. I will be making a follow-up video to this with another example using point-slope form, so please do check it out. I'm just about out of time for this video. I hope it did help. Please go back and watch it and leave a comment. if you like, and I'll see you again next time. Take care. Bye-bye.